Yeah. Yeah, I feel particularly happy about this as it's the first blockchain for developers meetup, so I'm honored to be here. So a bit about myself. My name is Rinke, and I'm a developer, but I'm actually having a background as an economist. I studied economics at the University of Rotterdam, and only afterwards, actually in my last year, I got interested in developing. Also in blockchain, a bit before that already, and I did my master on the topics of digital currencies at the University of Nicosia. Maybe some of you know about it. Anyways, this was an online master, and I had quite a lot of time to self-study and become more of a developer, and I focused on making smart contracts, and hence I am right now developer and moving around in the blockchain space. What I find particularly interesting about working in blockchain is the token economics aspects, which of course also relates to my background being an economist and developer. Yeah, and currently I'm working on Swarm, and I'm employed by IOV Labs. And IOV Labs is a company who does many interesting things in the crypto space. Among others, I think they're most known from deploying the RSK, which is a side channel of Bitcoin, running an Ethereum virtual machine, so you can make smart contracts on top of Bitcoin, and doing right now all the things about decentralized finance and all the things which are happening on Ethereum, happening now as well on top of Bitcoin. And we'll actually be using RSK blockchain also during the workshop. Yeah. So what we'll be talking about, I'll be doing an intro into Swarm. Afterwards, you'll have the opportunity to try out Swarm yourself, and I hope all of you have a laptop with you. Like, everybody has a laptop, yeah? And is it charged? Because here we don't have any power supplies, but okay, good. And after this, I show you an ephemeral anonymous chat application, which is somewhat of a more advanced application developed on top of Swarm, using in a very good way the features which the Swarm network provides. To show you what is possible apart from just doing a Hello World website, which is very boring, of course, but nevertheless, that's why we develop a Swarm. All right, so let's do the introduction into Swarm. So just to know, who of you already know what is Swarm? Yeah, that's quite a lot. I'm happy to see that. I think it's because I'm working here and telling everybody about it. Nevertheless, I'll just talk a bit about it. So, how it all started. Swarm, some of you might know that it all started actually at the same time as Ethereum started. Gavin Woods, at that time, who is one of the co-founders of Ethereum, he had the vision of Web3, and Web3, in his opinion, was we need something of a blockchain for decentralized consensus, and then we need something that allows decentralized and secure and anonymous messaging, which later became Whisper. And we need something for decentralized data storage. And he thought that if you have all these three components together, then we can really make the decentralized web where there's no control, and where we can have developed decentralized applications running without counterparties, basically. Anyways, this was his vision in 2013. He developed Ethereum. It's running at the moment. Whisper, for a real long time, was being developed. It's actually working, but it's so anonymous that it's actually not useful. Like, there's quite a lot of overhead to make it working, so not a lot of people started to use it. Fortunately, on top of Swarm, we can also do messaging. So right now, Swarm is being developed and is taking care within Ethereum, the Web3 stack, of both the decentralized storage and the decentralized messaging. So why Swarm? And this is a bit of a philosophical background in it. As we all know, like, information on the internet arises from the collective, which I think is the most valuable information on the internet, is that we're all interacting with each other, be it on social media or putting reviews on a website or whatever we're doing on the internet. All the information coming from that is more valuable because we're all contributing to it than if we would only on our own contribute to it. The problem with that is that this information is not owned by the collective, but is owned by private enterprises who are trying to make profit on top of this, or who are censoring content, or doing all kind of things on top of this collective information, which creates all kind of frictions. These frictions are that, for example, the creators usually don't get the value of what they are creating. It's like everybody of us. It also stifles innovation. For example, many people, I think, as we are developers, we probably have ideas how to improve upon Facebook, right? Or how to improve upon any application that we're using on a daily basis, but we can't because the backend data of these applications is owned by one corporation, so it stifles really the innovation. And also there's power conflicts, which we've seen with the Cambridge Analytica scandal. It's just not a good idea to have one company or one entity being in control of so much data, because right now they're even thinking that these companies are more powerful than the biggest governments in the world. So these are all three things which is important. Why Swarm? Because Swarm is really the base layer protocol where this collective information can be collectively owned by everybody. Yeah? Okay, so on a very high level, and this is really high level, how does it work? So if I'm uploading a file or a website or anything else to Swarm, then the first thing that happens is that this file or this content is cut into many small pieces of 4 kilobytes each. And all these pieces, they are being ordered in some sort of structure. It's a binary Merkle tree for those who know what it is. And then we're sending those chunks, we're sending them all to the network. But we don't have any say to where those chunks belong, because those chunks, they will travel in the network, and I think we'll see later on how exactly that works. They will travel to the location where the address of the chunk is closest to the address of the node who is hosting it. Right? So everybody in the network has an address, which is also, I mean, it's just his address in the network. He's identified by that. And based on this address, he is hosting pieces of the data. But because one single node in a network never knows which files he's hosting, he's only knowing that he is hosting certain chunks, which are maybe part of, I don't know, maybe 3 different websites or whatever. Anyways, I can show you a visualization. Yeah, so this is what happens first. We're having the source file, the picture, and then it goes to the chunker. We have many chunks, then we encrypt them. That's the first part. Then we put all those pieces, we put them in a binary Merkle tree. And you see here that the address of each chunk, this is in blue is the address. And then we package them, and from all those leaf chunks, we are putting them such that in the end, the whole file can be identified by one content address identifier. Yeah? And then we are sending all those chunks, we're sending them to the network, and based on the incentivization and everything, those chunks, they travel to the nodes who are supposed to host them. Oh, that's not so nice. Okay. Yeah? Okay, so that's really high over. And if you have any questions, then please ask. Yeah?
Maybe kicking open doors, but I want to ask it anyway. What's the benefit of this versus, for example, a service like Tor?
All right. Tor works with, like, the difference with Tor is that you can never have really like reactive web. Like you cannot, if you're having in Tor, it works in such a way that first of all it starts to trickle and you start to get a little bit, and only in the end you get the download speed increases and it goes really quick. That's good if you want to download movies, but if you want to have like a reactive web, for example, and have like a responsive web, then it doesn't really work. So, but we are really Swarm is built on the foundations, which I don't know, not Tor. What's the protocol behind Tor? The tip of my tongue, help me. No, not Tor. Never mind. Tor is something completely different. Tor is for Tor is completely different. Tor is for hosting websites in a normal way, but only having the addressing in a different way. Yeah. So Swarm is has some of those attributes which Tor has, yes, and we come to that later. We'll be explaining the retrieval, but Tor does not necessarily have the data in a decentralized way stored, but in Tor only the retrieval is anonymous. I think this is a difference. Sorry, I was confusing. I was hearing another protocol, which I tried to compare, but good. Answer your question? Yeah. Yeah? More questions? No? Okay. I'll go a bit more in detail. Some concepts. In Swarm, you have the overlay address and an underlay address. And the overlay address in Swarm is an eNode ID, and this is enough for a computer to identify if I have the overlay address, then I can connect to this particular computer. Then on top of this, every node is also identified by its overlay address. Sorry, underlay is this and overlay is this. And overlay address is, by convenience, is also an Ethereum. It's the same as an Ethereum address. And this overlay address is used to create a Kademlia topology. Now, what's a Kademlia topology? I have a bit of a complicated picture, but you must see it in this way. In this network, there are 15 nodes. You have nodes who is identified by the overlay network 000, 001, 001, blah, blah, blah. And the feature of a Kademlia network, of a Kademlia topology, is that you only have to be connected to the logarithm of the amount of nodes in a network to have, to be able to make a connection with all the nodes. So for example, we have this particular node. This node only has to be connected to one node in the green box, one node in the blue box, one node in the red box, and one node in the orange box, to be able to make a connection to all the nodes in the network whenever this is needed. And this is a very important feature because, of course, as the network grows, this is logarithmic, so you only have to be connected to only a subset of the nodes in order to be able to route and to request chunks and messages from the whole network, basically. Yeah, so this is the connections which the node have. And for example, if this particular node wants to request a chunk that has the address of 000, he knows that this particular chunk, the address is the hash of the chunk, the hash of this 4 kilobytes data. It starts with 000. Then he knows, okay, since it starts with 000, I have to request it from the node who is very close to that address. So since this is only very small, he is going to request it from node who happens to have exactly the same address. So he wants to make a connection with this one, but since he has only one connection in his whole green box, he might be only connected to this guy. He's just asking this guy, okay, do you have this chunk? And this guy says, well, no, I don't have it, but I can forward your request to somebody who is closer, right? And since this node also has exactly the same Kademlia topology, you have to switch it a bit. He might ask it to this guy, and this guy might ask it to this guy because he has direct to this guy because he has a direct connection. Mm-hmm. So what you do? Good question. Thanks for that. I needed this this picture which you had. So what you do? You have this binary Merkle tree, right, with the root hash. You're requesting the chunk with the root hash. In this root hash, you unpack the root hash, and instead of actual chunks with the data, you're getting instructions to where to find the other nodes, right? So you unpack it. Then you're going to request those, which might be either the data or might be more instructions. So I'm going to request it. I have now suddenly 144 instructions for request. I'm going to get those to me. I'm unpacking them, and let's say it's the data now, and I have the data, and I reconstruct it, and I have my file. That's basically how it works. And I have basically like a virtual connection to all the nodes in the network because of this Kademlia topology. Yeah? Yeah, so we need to store the data in the different areas of the network, particularly because of the decentralization, right? Because we need to have this data spread out over the whole network such that, and of course there's duplication, we're also thinking about erasure coding and all some kind of advanced things. What I want to say? Yeah, anyways.
As far as I see it, the interesting part here is that you have a fixed amount of maximum steps, basically, based on volume.
Yeah, exactly. So, yeah.
So you need twice the amount of nodes of one extra hole.
Yeah, yeah, that's correct.
That's basically.
Yeah, so if you have what you say indeed, if you have a network of n nodes, you always know that no matter like how big the network grows, the maximum amount of hops which I need to get to my chunk is the logarithm of n, of the size of the network. That's indeed, thanks for that, it's an important feature of Kademlia. Yeah?
So I think most things are already answered, but is then in Swarm the replication implicit? Because I'm trying to compare to IPFS because I'm a little bit familiar with that. But in that case, I provide something, I pin it, and somebody else can choose to replicate it, right? But if it's not replicated, it's gone. And
Yeah.
in Swarm, it's the case that it's always distributed and replicated everything.
Correct. Yeah, that's the biggest difference with IPFS. Like basically what IPFS does, IPFS stores instructions on the underlay address. So IPFS has the distributed hash table, and basically what is distributed in IPFS is this lookup book on where do I find this file. So I'm asking the DHT where can I find this file, and it reports me, look at, make a connection with this node, you're making a direct connection with that node, and you're getting the file. That's how IPFS works, and if I'm downloading the file, then on top of this I'm also going to update the DHT, and I'm also announcing, okay, I have it as well. But basically, the storage of the actual data is not really decentralized. What is decentralized is the fact that we are kind of opening up about who is storing what, and we're making it really easy to replicate this content. But indeed, the big difference that in Swarm, the actual data is residing at the whole network. Yeah. Good question. Thanks for that. And maybe a month ago I couldn't answer it, so I spent some time researching it. Yeah. Because I get this question very often. Yeah. Sorry? I mean, yes and no. It is still a decentralized network, of course, so there is some replication, but let's say, and we're going to this slide, let's say we're having a chunk which is hosted here, and this chunk is part of the file, and there's some replication, and suddenly all the nodes with the prefix 000, because of course in a real network the address is not 000, but it's like much bigger, but suddenly all the nodes with the prefix 000, they go offline, and these were the only ones who were storing this particular file. And you didn't do any other precautions in order to ensure you can pin it and you can have some incentives, but you didn't do this. Then your file, I mean, it will miss one chunk and it might be corrupted. So this is always a tricky thing of decentralized networks, that you don't know how the network behaves, basically. But that's actually a nice bridge to my next slide. Yeah?
So the incentives structure basically lets me determine how many times the information is replicated.
I'll come to that.
Okay.
Good. So that's like basically how the network works. Sounds all very nice, but who are these nodes going to be? Why are these nodes going to replicate your content, use the variable hard disk drive to put chunks from people whom they don't even know, right? So, and this is very important aspects of Swarm, which are the incentives. And basically incentives is what makes this clock tick, so to say, because we need to incentivize nodes to join the network, we need to incentivize them to stay in the network, and we also want them to make a bit of profit, because otherwise how are we going to ask them to do a service for us. And for this, we actually had, I don't know how long ago, it was probably somewhere in October, we had a very nice workshop here in the Lisk Center. So we won't go too deep into this right now. But I want to make you an offer, and if you, after this meetup, think, oh, this is super cool and I really want to hear more about these incentives, then I think if we have like 5 people, I will be happy to, I don't know, do maybe 2 hours and we can do another workshop on the incentives on Swarm. So if you're interested, come to me after and we're going to arrange it. Yeah? So I want to explain about the Swarm accounting protocol. And this should be a GIF, but it's not a GIF. Okay. Anyways, what we're doing in Swarm, we're keeping track of who retrieves what. So I'm having all these peer connections with my nodes, and I'm keeping a balance. And this balance is kind of seen here. We called it the chunkometer, just a funny work name. And I'm keeping a balance with you. So you're serving me a chunk. Right now, you have a bit of a positive balance. Next time I'm going to download something, I'm serving something to you, and you have a bit of positive download, but now you're going to download the full seasons of Game of Thrones, whatever you're going to do, so you're going to request a lot of data from me, and this chunkometer, it goes to a certain threshold. Up until this point, we haven't done any transaction, we're just keeping track of our own balances in our own account. What happens right now is that you're expecting, I'm expecting a payment from you because you've been downloading so much, and well, you're a good node. I'm also a good node, so you want to stay friends with me. So you're going to send this payment to me, and this payment is a payment on the blockchain. It's not an on-chain payment; it's actually an off-chain payment. But anyways, I'm having some data which I can later on use to cache it on the blockchain on-chain if I want. So now the balance is 0 again, and we can kind of continue our business. So this is accounting for bandwidth. Yeah, what I already said, I did a workshop and you can read it there. You can also do it on your own, I think it's possible. But I will be happy to host it. On top of this, we have more incentives needed because of course only incentivizing for bandwidth is not enough. We also need to incentivize for actually storage. What happens if nobody actually requests a file, like why would I host this particular chunk? Which we do by means of postage stamps. It's a system really analogous to the international post system. And postage lottery is a way to redistribute the profits on top of this postage stamp system to all the nodes. And then we have some negative incentives. It sounds very negative, but it basically means I am able to make a contract with you. You're going to promise to me to store chunks, right? And if you don't do it, then I'll be able, and I can prove that, then I'll be able to take some of your deposit on the on-chain smart contract. That's all it goes. Like much more than this, we can never guarantee in a decentralized network. We can never guarantee that your content will always stay online, but we can guarantee, or not yet, but it's work in progress, we're trying to guarantee that at least if you're promising to store the chunks and you don't do it, then at least you should incur some damage as well, and I should be compensated. And pinning, like in IPFS, is very common to talk about pinning. In Swarm, we also have something like pinning. It works actually very different than in IPFS, but we also do this. Yes. Okay. Good. Upload a basic website, part 1. So what you need, and I think as we are all developers, you need Git to download a repository in GitHub and tar to unpack a binary file. If you don't have it, just put your hand up. Good. We're all set. You can find the instructions so that you can copy paste instead of like typing everything on github/acneer lcu_developer_workshop. So if you all just put this on your own screen, it will help. Yeah. Okay. Everybody got it? Good. Sorry? Which network can I use it? Ah, good question.
Oh, it's a good one. It's
yeah.
Yim Public, and the password is join the, and on GIN
Yeah, got it? All right, so the first thing is please download this repository, which you are having in front of your screen right now. You can do it in your command line by git clone and then this URL. You can get it from the GitHub UI. And if you've done that, then you can navigate to https://swarm.ethereum.org/downloads. You go to a downloads website, and there you have the choice of downloading binaries either in Mac or Linux or Windows, whatever you prefer. And then, of course, download the binaries and unpack them with this command. If you have done that, then put your hands up, then we go to the next slide. And if along the way something doesn't work, just put your hands up and I just come to help.
Unpack it in the same folder?
It doesn't matter. Just unpack it somewhere. Actually, it does matter. Yeah, in the same folder. Yeah. Yeah, in the same folder. In the Git repository.
In the Git repository.
Yeah. Yeah. See? Yeah, exactly. Yeah, put. Yeah, that's how I planned it. Good question. And of course, later on you can put it anywhere, but just have some scripts which expect it to be in the Git repo.
Oh, cute. Yeah,
Yeah, who is here so far and unpacked it? Everybody? Somebody not yet? Let's just wait to get everybody on the same page. Yeah. Yeah, question?
I am an idiot, but I downloaded it,
Yeah.
checked it, and this is what I get.
All right, good.
But that was not a tor, that was a zip. Is that okay?
Ah, of course, because I was making this with Linux.
No, I'm just
yeah,
checking if
yeah,
that's
yeah, exactly.
executable. I get an executable.
Yeah, you get an executable. Yeah, you know, I have some scripts. It might be a bit different.
Exactly. So
Yeah.
I'm like,
Yeah, exactly. Good. Who has Windows? Okay, who is Linux? Okay, Linux guys will work anyways because I tried it today. Mac also probably work. Okay, Windows guys, maybe some of the scripts we need to adjust them a bit. We'll manage it. Yeah, so everybody has the executables now? Not? Do you have it? Yeah. Yes, voor een open website. Ja, dat is oké. Ja. Ga eens één folder naar boven. Dat is in de downloads. Ah nee, je hebt hem in je downloads gezet. Je wil hem eigenlijk in je Git repository hebben. Ja. Ja, dus je wil... Ja? Nee, je hebt hem ernaast. Doe hem er... waar is je... Heb je deze al gedownload? De git clone?
Nee.
Ah, oké. Yeah. So first step, git clone. And then in this repository you put your executable, right? Yeah. PM?
Ja, ik had even jouw git-clone gekopieerd. Daar loopt helemaal vast in Windows.
This should be the follow section, right? So I need to put this one inside this git directory.
Yeah.
Or
Yeah,
I need
yeah,
to
this
go
is
back to
okay.
the previous script.
No, this is okay. Let's see, because then the scripts
This is the
are...
directory.
Yeah, I think that's okay. Yeah. Yeah, if you open scripts, we just have a start sh. Let's see, we do...
Checks for current directory.
Yeah, it's okay. Yeah, yeah. Yeah, I think it's fine. Yeah, because the root is the git repo. Yeah.
But it should execute this form, but here I didn't keep this form. That means I need
This
to
is the swarm. Yeah, yeah. So the directory is the swarm. 0.5.6 is this one. Yeah, that's fine. That's good. Yeah. Nice. So who has it already? Like, yeah. Maybe I show my laptop what actually the end result will be. Can I? No, I think I can't. CD. Yes, you guys. This is a bit shit, right? This is the folder. This is your Git repo. Also your developer workshop, and here you have the folder, the unpacked swarm. This one we're going to make soon. Scripts you have, and this was like. Sorry for the font size. Anyways. Yeah? Help?
Ja, we hebben problemen omdat die nap dus anders genaamd wordt. Dus ik heb hem nu Swarm genoemd gewoon. En dan heb ik hem hier aangepast naar Swarm.
Yeah.
Maar hij vindt hem alsnog niet.
Oké, nou. Je bent al 3 stappen vooruit. Okay, so everybody who doesn't have it downloaded and unpacked yet? Everybody has. Good. Then we're going to go to the next slide. Alright, so the next step, which will work for those who have Linux, and I think those who are working on Windows, we need to adjust the scripts a bit. But let me explain what is happening. I'm asking you to run chmod.+x and then scripts/run.h8. So here I have a script, you make it executable here, and here you actually run this script. Can you all read this? What's written here above? Alright, so what's happening here is that we are calling the swarm executable wherever this is. Like if you're like you don't have to run the script, you can also just call it directly in the command line. You say swarm. You're specifying which data directory you want to do, and this is not even necessary to do it like this, but just I thought it for the sake of like keeping everything in one place is like just take this, also put it in the Git repo, and here you see that it is, yeah, asset store. I called it asset store, swarm store. Next one, also not really relevant. You can skip this. Is a flag store size. I think by default it is like 25 gigabytes. Maybe for some of you it might be a bit too much, and actually if you run it just like this, it will eventually fill up into 25 gigabytes. If you don't want this, you can adjust it to a bit lower, like, I don't know, how much is this? This is 100,000 chunks. So 100,000 times 4 kilobytes, that is the amount of bytes the size is. And this is an important one. You can't skip this one for the sake of the workshop. Is RNS API. And that needs to be this, this address here. Yeah, so for those on Windows, maybe you cannot just run this script so easily, but you will be able to do something similar like this. Yeah, you don't necessarily need to run the script. And then you can start Swarm. And let me know if it works. And if it doesn't work. But I expect it to work.
And you have to follow the scripts that are mentioned in the readme.md file, right? Because we do not have the run.sh script. We have start run.sh.
Pardon. If you don't have run, then just then start the typo. My mistake. You need to call start.sh. Yeah.
Can I ask a question in the meantime?
Yeah.
Because I see RIF everywhere. I see RIF in the Git and then on your shirt.
Yeah.
What is it?
Okay, good question. RIF is it's a project from IOV Labs, and IOV Labs, as I already explained, we built EVM on top of Bitcoin, and they did a token sale on their own blockchain, and their token is called RIF. It stands for Rootstock or RSK Infrastructure Framework, and the idea of RIF is to build developer kind of layer around this base blockchain layer, where there's like things as the RNS, for example, the RSK name service, or decentralized data, or decentralized messaging, and all these things which is needed for a decentralized web more than only the blockchain. That is like the task of RIF, and we're developing that. So from that end, like I'm officially working for RIF, or actually for IOV, but I'm working on RIF. But we made a partnership with Swarm to make the decentralized data storage. So we're also working with Swarm, and the idea in the end is to make one unified Swarm network where people can pay both with RIF and with Ether, and it doesn't matter. But anyways, like they are interested in what Swarm is doing. This allows me to work on this project while still working for IOV Labs. That's RIF. And you'll get some RIF later on. I'll send you some. Yeah.
Got this error starting protocol stack.
Invalid argument. Which argument is false? IPC bind invalid. The IPC endpoint is no longer as store BCC. Okay, can you just run Swarm? If you are
I cannot run this one. I maybe need to
yeah, then you need to run Swarm. /swarm. Yeah. Yeah. Now it works. Okay. The only thing what you need to do, like the only relevant flag is the RNS API. So just this one you need to copy. This one is not so important. This one also is not so important. Yeah? Okay. Yeah?
this one also.
This one is not so important because this one, like now you have your data directory somewhere else.
So
RNS API is actually the only thing which is really relevant.
okay, so I can directly run this command with these variables.
Yeah. Yeah. Exactly. Yeah.
Maar wat je natuurlijk is gewoon een
Yeah. That's fine. Yeah.
Swarm node zelf draait.
Yeah.
Daar begin je niet mee.
Yeah.
Jij bent even anders voor de Windows Swarm node van een downloaden.
Oh, okay. Yeah. Yeah.
Als het goed is wel.
Okay, so what we're doing here, by the way, like we are actually starting our own Swarm node, right? And right now you're booting up your Swarm nodes. What is happening is chunks are getting synced to you because, of course, you're getting others in the network, and the network rebalances because you need to have chunks which are closest to your nodes, right? This is all happening in the background. You don't have to do anything. You have a question? Yeah?
I'm getting a lot of really errors and warnings and errors and warnings.
Good. If you have it running, if you think you have it running, then I'm going to ask you to navigate to a particular website. You can go to this website, localhost colon 8500 slash BCC double colon slash blockchain4devs.rsk. Then you can actually test if it works. Because these slides are hosted on Swarm. So you can, if you are running your own Swarm nodes, you'll be able to request this file in the browser. Yeah, RSK. Yeah, I mean, this is I just uploaded these slides just before I started. I uploaded it to Swarm and.
Now what I mean, because it's not like non-human readable hash, this is the RNS?
RNS, yeah, this is, yeah, so a decentralized, do you have it?
No, I know ENS, so...
Yeah, no, but do you have the, ah, you don't have it. Let's see.
Well, maybe I made a typo.
Yeah, you probably made a typo.
Blockchain4devs.rsk.
Ook, huh?
Allebei dat zijn natuurlijk.
Ja, is niet te lezen vanaf hier. Je moet eventjes ietsjes dichterbij gaan staan en dan eventjes even goed lezen. Want waarschijnlijk heb je een colon of een slash slash of zo. Waarschijnlijk is...
Ja. 500 slash BZZ.
Got it? All right, so that's the first step from uploading your own website is trying to download content from Swarm. So your Swarm node is working.
Kan het zijn dat als je een VPN gebruikt die dit breekt?
Nee, het is slash bcc dubbel slash
bcc dubbelpunt slash blockchain4devs.rsk slash zelfs.
dubbel slash blockchain4devs. Ja, dat ga ik inderdaad. Kan zijn dat je VPN uploadt. BCC dubbel slash.
Ja, toch?
Ja.
Oké, laat hem zo uitzetten.
Even probeer hem nog een keertje.
Oh, is eens connected.
Ja, probeer hem nog een keertje.
Rinke, can you put a magnifier on that address?
What?
Can you put a magnifier on that address? Because
I don't know how to do that. But I can put it here. Yeah.
Now it's loading, so I think it's just unstable or something.
Okay.
At least now it fails to load PDF, so it knows something is there.
Ah, okay.
Look at there.
Good. Is this better?
yes.
Mij is ook gefeest, toch? Ja, je hebt hetzelfde band.
Gaat hij hier? Heb je een mic?
Oh ja, ik heb hem uitgezocht. Ik zit op mobiel internet.
Ah, oké. Ja, ja. Dat is wel handig. Yeah, so don't do this if you're only on mobile internet. It will suck all your data. What?
It just redirects me to the same address again. So it, yeah, exactly like this.
Mm-hmm.
And it goes back to this website.
Localhost HTTP. Moet even. Nou, kan je ook hier doen. Blockchain4devs.rsk.
Alright, so it's working.
Yeah? Good at working. Ja? Oh ja, dan moet je eventjes opnieuw laden. Even kijken. komt hij. Ah, nog niet.
Dat is gewoon een
Ja.
kwestie van gewoon een rol houden.
Ja.
Wat is een basic set?
Yeah, I'll explain it. Okay, so what you see here, for those who have it, and if you don't have it, maybe help your neighbor a bit. What you see here is localhost 8500. This is the port at which Swarm is running and which it accepts requests from your node. If you don't have Swarm running yourself, then we're also hosting a gateway. So if you, for example, want to tell your friend about it, instead of localhost 8500, you can go to, what is it? Swarm gateways. Yeah, so if you don't have your own Swarm node running, you can, instead of localhost 8500, you can go for a public gateway, which is swarmgateways.net. BZZ is like the protocol, how we just, like HTTP is like an identifier for our protocol. And blockchain for devs.rsk, like if you mentioned attention in my previous explanation, I told that all the content is identified by this root hash, right? But what I did, I use a smart contract, which is some sort of DNS server which resolves the hash, which resolves this address, blockchain for devs.rsk, to a hash. And later in the demo, you can all do it. I can send you some RBTC and some RIF tokens so you can use it. So that's this, but of course under the hood this is a hash.
Possible to give to any file then, something like that?
Yeah, to any file. Yeah, it doesn't really matter. It's just resolving a root hash like this address to a root hash. And by the way, this is .rsk is the extension of the rootstock name service. There's also an ENS, the Ethereum name service. It also works with Swarm, but it's basically the same smart contract, but a different blockchain network. Yeah? More questions? No? So who has the PDF? One?
I don't know if it actually loads. I just have a black
You have it, Susan?
I have a black screen. It's a PDF, but
Man, what's happening with your laptops?
It takes too long to download, so it just fails after a while.
Ah, okay.
That times out in the terminal. But is it possible that everybody's connected to the same closest node right now and they kind of have crappy internet and that's why everybody's getting a timeout? Just theoretically?
Maybe there's a no, I don't know. I don't know what could be the case, but let's see. We're just going to do the next slides. We're going to do this website, and maybe this works better. You have it? Yeah. Yay! Good. At least somebody got it. All right. Okay, so this works, right? Everybody has done the Swarm is running, and leave it running in a background process if you're not on your own mobile internet. The next step is to upload a website, right? And this is actually very easy. Also here I have like a small script for those on Linux, and if you're not on Linux, then you need to understand maybe a bit better what actually is happening here. Can you see this, or is it too small? If it's too small, just say it, because then I just put it in my HackMD. Yeah? So what you're doing, you're running this command. You're running Swarm, then you do giving a flag -- recursive, which means we're not only going to upload one single file, but we're going to upload a directory. Which of course is the website, with the image and some HTML. So we're going to upload a directory. Here we're giving the entry point to this directory, which is our index.html. And then we go saying up, and then we're giving the actual directory which we want to upload. So this is the semantics of the upload, and this hash, you don't have to do it. Yeah. So if you have Swarm running, then this should be very easy, actually. And in your command line, and do it in a new terminal, and in your command line, after you run this one, you need to wait a bit, and then you get a hash, and it will instruct you to go and download this website. Got it?
What the chance if someone uploads the file, or the chance that some chunks will land on somebody's laptop over here?
I don't know how many nodes there are in the moment in the Swarm network, but I think.
But they have clauses for sure.
I mean,
chunk, perhaps?
sorry?
They have clauses.
This is the geographical closeness. This is not the closeness in terms of the network topology, because the closeness in the network is determined based on you're taking two addresses and you do the XOR distance between the two. So you're comparing them and you're getting a number. So like geographical closeness doesn't matter at all. Yeah.
You want me to save this file as run.ha? Because I don't have a run.ha in script.
It's in the RIF.
No, it says up. Sorry, my bad again. Again a typo. Up.sh. Yeah. Yeah.
Okay. Uploading web pages to oh, for fuck's sake.
Yeah. So first step is go to your own browser and navigate to your own website. Second step is navigate to the website of your neighbor, but of course your neighbor was uploading exactly the same website, so that's no fun. So you're all programmers, so you just edit your HTML a bit, make it advanced, make another picture or whatever. And then you can maybe share your hash via email or whatever to your neighbor if you want. If it's too much effort, you can also go to my website.rsk, and then you'll find a website which I made, which, spoiler alert, is exactly the same as you just uploaded. Sorry? Yeah, so that's here. This is exclamation mark. Well, you didn't really actually upload a website because this website was already on Swarm. So under the hood, of course, it's not going to store chunks twice. But if you change only one small bit, it will not upload all the chunks are new, but it will upload only this kind of additional change which you made new, and it will, yeah. Yeah? Got it? No? So let's say you have in this website, and instead of hello world, you say hello world exclamation mark. Of course, your hash will be completely different now. But maybe 99% of all the chunks will still be exactly the same to the hello world website, right? Because the data is exactly the same still.
Well, that's how it's split in chunks.
Yeah, okay, so this is split in a, yeah. No, this is split in an intelligent manner, so we have, like, if you upload exactly the same website but have a small change, then most of the chunks will be the same, but maybe one thing will be different, and at least the address will be completely different, of course. Yeah, so just make a small change to your own website, because we're also going to need this in a follow-up step. Yeah?
Bij mij zegt hij dat er run.sh, dat bestaat niet.
Nee, dat klopt. Ik heb een typo gemaakt. Het is up.sh.
Dus 2 keer dit.
Ja.
Waarom 2 keer?
Daar maak je hem executable. En daar
Ga je hem
execute je hem. Ja.
Hij zei van, die heb ik niet. Dan gaat het.
Ja. Scripts. Ja. Ja, ziet er goed uit. Even wachten.
Ik zag wel dat hij wordt niet echt super warm.
Mhm.
Dat is wel,
Ja, dat is.
een beetje is heel
Ja.
fijn.
Dat is hij is aan het zinken nu. Als je een nieuwe node bent, dan. Ja.
Succes.
Okay, so I think we have it now. Yeah. Okay, so congratulations, you uploaded your website on top of Swarm. Woohoo! Nice. Okay, next step. If you want, we're going to add the content, the decentralized DNS, RNS. and for this you actually need some real crypto. So I suggest I'm going to distribute this. You need 2 RIF, and you need some RBTC. And RBTC stands for rootstock bitcoins. And as this is a packed sidechain, it's actually one-on-one exchangeable to a bitcoin. So I'll just send you a bit to pay for the transaction fee. Yeah, just nice for you to know. For those who are no Ethereum developer, do you have a Web3 enabled browser, meaning you're either running Brave or you have a MetaMask plugin? Yeah? You have it? No? Yeah, you can try to. I think easiest is to download MetaMask, and maybe also for the sake of time, it will take some time to get this up and running. So, anyways, I'm going to make a hackmd. This one. Tiny URL. Yeah.
So I uploaded the chip. Where can I see it?
Well, in your command line, you got an instruction on how to view it. No?
No, it says uploading it to the web homepage, and then it says nothing.
Oh, then you have to wait.
Then I have to wait.
Be a bit patient.
Also share the slide and info to meetup afterwards, so if you want to try it home later or just want to try it again, that's also
All right. So you can go to this website, and then you will come to this particular hackmd. And if you have an Ethereum address, put in this hackmd your Ethereum address, and please put only one, because I'm going to send you some crypto on this address. And how much time? How are we with time, actually?
It's 9 now.
It's 9, and what time are we supposed to stop?
Around 9.
Around 9.
We have some time.
Guys, do you want to continue, or are we going to stop?
How many people are still like in the game? How many people are
Because we can stop now. I mean, we uploaded our website to Swarm, so this was in the end goal. But this is only nice. So
So maybe we'll kind of wrap it up with a few drinks, and then we'll make everything available online afterwards? Or is still everybody...
maybe this is. I want some free crypto. Okay, let's do it like this.
Yeah.
I gave you guys this tiny URL. I'm also going to send you my my email address is rinke@iovlabs.org. Send me a mail. Put in content. Let's say dev workshop Utrecht. Oh no, let's call it as LCU. Put in your Ethereum address, and I will send you some stuff, and the slides will be shared afterwards, and so you can do it by yourself. Yeah? Yeah, I'm sorry guys. I'm going to send it tomorrow morning. Yeah, then I had a demo of somewhat of a more advanced slide, but I guess we're going to skip that. But anyways, for you to say, this was Hello World, of course. On top of it, you can make anything that you can imagine. But also Swarm has some very interesting features. On top of content address chunks, which are actually feed chunks, so this allows for streaming of data or like mutable resources, and this chat app was using this. We don't have time to show this right now, but
how long, because it's just a demo, right?
yeah, it's just a demo. 5 minutes?
I'd love to see the demo.
Yeah, we want to see the demo? Okay, let's do it. Now it's of course always when you do a demo, you need to do it quickly. Swap. Swap chat, right? Swap chat? No? Swap chat. Yeah. And by the way, if you want to navigate to this GitHub repo, it is github.com/felfella/swapchat. I'll also put it in this HackMD. This one. All right, so what I'm doing here, this one I already did, this one also already did. Yeah, we also had a nice script. And I do localhost 500. I'm also going to upload my own website right now. Once that's done, we're able to view it. And then we're maybe going to do a chat with you. I want to chat, yeah. 1 second. We first have to upload, make our own chat application. Because the idea of this, these guys, they were a bit annoyed. They wanted to do private chat without the need to install like a Telegram or whatever. And even Telegram is not super private because it still stores quite a lot of metadata, only not the content of your actual messages. So they wanted to create anonymous ephemeral chat, and ephemeral means you're just creating a chat for the purpose. We're going to talk to each other, and afterwards we kind of throw it away. We don't need to, it's like a temporary chat. Okay, so I just uploaded this temporary chat, and now I'm going to navigate there. Okay. It's loading, downloading the chunks. Yeah. So if you're on your mobile phone, you can do this right now. The only thing what doesn't work is since I uploaded it on localhost. Of course, on your mobile phone, you can't go to localhost. So what I do, I'm going to put this in this HackMD, and those who are still here, they'll be able to copy it in their own browser. Very long URL. There's some data there. And if you have this copied in your own browser, and it can only be one, so let's not do it with 10 at the same time. Like, who has the HackMD still open and Swarm running? Mick? Okay, you're going to volunteer. Okay, Mick is going to volunteer, sorry. Okay. And yeah, you can, if you have this. You send the message? Yeah, there's quite a lot of information there. Like, I have it on the slides as well. You'll be able to see it, but basically what's happening right now is I think a Diffie-Hellman key exchange based on some things which are happening in the swarm, and it's basically we're establishing a completely anonymous chat over a public channel using the underlying capabilities of Swarm. So it's actually pretty cool, even though it looks, I think it looks cool as well, like old school. No, it uses completely the Swarm network, so we're not establishing any direct connection. Everything happens with mutable chunks, which is a bit more advanced than the chunks I just talked about. Yeah. Yeah. Yeah, the handshake between Mick and me, but we are not having a direct connection. In between us is the Swarm network. And based on the features of the Swarm network, basically nobody can even know that we are chatting with each other. Like, it's not only that we are anonymous in the content, but it's also that we are completely anonymous. Nobody knows that we are sending chats to each other, only those in the room. Did you send already something, Mick?
Yeah, it's still loading.
Still loading, but...
How do I get to this thing again? Sorry,
no, you can't. It's only possible with 2 people at the same time, otherwise the application breaks. Yeah?
Sorry, so why can it only be one-on-one if there's no validation on who's in there, it's only in the swarm? So I expect it to like be a log, so everybody should be able to write to it.
I think so, but this is an application which was developed in 1 week, and the developer told me don't try to work on more people because then it crashes. So. But of course, this is like one chat, and you can work on it and extend it and make it better, or make it maybe a group chat. I think it's possible. Like basically, you can do these kind of things. Yeah.
Theoretically, if everyone has the same key, and you access it, or you have you help a key exchange, then two parties negotiate. If anyone has it, eventually there is an encryption.
So on the background, there's actually
Does it work, Mick?
connection between there to know satisfy that. So yeah, I'm connected now.
Did you send a message already?
System encryption.
Okay.
Both parties use the same key.
Let me try to chat to you.
Okay. And I thought it was more like a safe space that if you have the URL, you're able to write it. But there's actually authentication.
Okay, some problems. Never mind. I tested it this morning and it worked, and it's always with demos, of course. It's a bit funny, but this is it, guys. Thanks.